students, we're going to be going over the Pythagorean theorem and the distance formula in this video. These are both concepts that you have seen previously in other math classes. It's just really important for us to remember those two concepts as we go into this next unit, because we're going to use them as building blocks. So let's look at the Pythagorean theorem first. This is the theorem that many students just have locked into your brain. It is the a squared plus b squared equals c squared. Most of us do remember that theorem. A few things to remember, though, is that the Pythagorean theorem is used in solving for an unknown side of a right triangle. It has to be a right triangle. We identify that right triangle by having that 90-degree angle, in the corner here. And then we can find the side lengths of A and B, where C is always going to be the hypotenuse. So C is the hypotenuse that is the side opposite of that 90 degree. Most of us do remember all of that about the Pythagorean theorem. The distance formula, however, is a little bit more complicated. We have like the square root business. We have x2s and x1s being subtracted. So I wanted to prove to you that these are really the exact same thing. So let's look at an example to help me prove that to you. I'm going to start with a line segment AB. So I can see that it starts at a point A, ends at a point B. Our job is to find the length or the distance between A and B. To start my process, I'm going to create a brand new coordinate point. Let's call that coordinate point C. And since it is on a grid, I can find the coordinates for that point C. Now, I chose point C very, very specifically. It wasn't just random here and there. I wanted to create that point C so that it creates that specific 90-degree angle there. I am creating that 90-degree angle because I have a vertical leg that's coming straight down. So it's kind of following along that y-axis. That's called a vertical leg. And then we have a horizontal leg that we can see that is connecting A and C here. So to find the Pythagorean theorem, or to apply that Pythagorean theorem, I need to find the side lengths or the lengths of the sides. So I'm trying to find A to C. Now, we could just count that out on that grid, but we're also thinking about if I know where something starts, it starts at 1, and where something ends, it ends at 7. To find the length between those, we simply subtract. So I'm using that simple idea, finding the lengths of my side lengths. So it starts on the vertical leg, it starts at 1 and it ends at 4. So what's the length in between? We find that through simple subtraction there. So once I know the two side lengths, I'm able to plug that into my distance formula. So I have some unknown. That's my hypotenuse. Almost said hypothesis. My hypotenuse squared equals side length A plus A squared plus side length B squared. Now, of course, we could simplify that to, instead of 7 minus 1, we're going to simplify that to a 6. Instead of 4 minus 1, we're going to simplify that to a 3. And I'm following my order of operations that we all know to be able to solve for that side length, or that distance from A to B, which we now know is to be a square root of 45. So I'm going to now prove to you that that is the distance formula, but I'm not going to use numbers anymore. So I have coordinate point A and coordinate point B, but to represent that these are different coordinate points, I kind of labeled them slightly different to be an x1 compared to an x2. So I'm following that same process that I did. I create my 90-degree angle with a new coordinate point. Move your face. I'm able to find the coordinates of that because look, in a vertical leg, x's don't change. In a horizontal leg, the y's don't change. So that horizontal leg, it didn't go up and down, so it didn't move at all on the y-axis. So it makes sense to have the same y values. So now I'm able to find the new side lengths, or the lengths of those two sides, because we subtracted, just like we did with our numbers, but now we're just using x2 minus x1 and then y2 minus y1 to represent the length of those two sides of the triangle. Plugging all of that information into our Pythagorean theorem, we have our hypotenuse. I labeled it D. So hypotenuse squared is equal to side length A, which is x2 minus x1, that's our horizontal leg, squared, plus y2 minus y1, that's our vertical leg, squared. And then simplifying, we don't want to solve for a d squared, we want to just normal old d. So to inverse that exponent of 2, we use the square root. And check that out. That is our distance formula. So I hope in this video, I should not only remind you of the Pythagorean theorem, I also remind you of the distance formula, and then also prove to you that you can find the distance formula on your own. You don't need to remember all of this square root nonsense. So please reach out to your teacher if you have any questions.